Welcome to another episode of Demo Days. Today, if you saw the title slideshow here, we're doing a demo showing how we could capture Wikipedia changes, page changes, and having Decodable transform and prepare that data and send it to a Tinybird server, which is a SaaS serverless service that provides API endpoints to the data that you just sent it so that you can use it in your own applications. If you look at the diagram here, you'll see that we're capturing data here at Wikipedia. This is a service called Wikipedia that provides these endpoints and feeds for us to capture and send. In this case, we're going to send it to Amazon Kinesis first. And then we'll use Decodable to consume that data, transform it, enrich it in here, and then fork it to two different places, one of which is Amazon AWS S3 in a bucket. And then we'll send it to a Kafka in Confluent Cloud. And then Tinybird will read that from Confluent to expose REST APIs. And then we'll have a little simple web application that consumes these REST APIs to show real-time changes, real-time dashboard in these applications. Obviously, these applications could be in the dashboard or a phone application generating alerts and so on. All right, let's get going. Okay, so what I'm going to show first, get rid of this, is a different version of the pipeline. We're going to use this to kind of walk through the parts of the flow of data, and then at the end we'll show you the actual application. All right. As I said, there's a thing called MediaWiki that provides these APIs. And if you look down here, here are some of these endpoints. And I'm actually using this one down here. If you go to that one, there are things called actions that they provide. It's just different types of feeds that they provide to you. The one that we're going to be looking at is this one, a feed of recent changes. So we click that. This is like the documentation for it. And then you could test it by clicking here, examples. It'll pull it up. And that's what it looks like. It's basically an RSS feed. What we're going to do is use just a simple Python app to consume that and send that to Kinesis. So that's what this application here. If you go to the Decodable GitHub account, there's a repository called examples. If you go into there, you'll see Tinybird. You'll see a bunch of others as well if you want to take a look at those. But we're here for Tinybird, and then here are that same pipeline, and we're going to look at this application here. It's just a Python application that sends data to S3. The first thing you'll need to do is populate a .env file with these properties to kind of get the whole pipeline built up easily with all the credentials. So you have to get all these things first. Get yourself an account on Confluent, Decodable, and on Tinybird, and obviously AWS, so you can create your Kinesis stream. But all we're doing here is that we're pulling that same feed that is exposed through MediaWiki. We're just capturing the entries in it. We're using this here to build our Kinesis client, and that's through this library called Bodo3. And then we get a client, and we just iterate the records and send them to Kinesis, which is this K here, put record. Okay, we'll do that every 10 seconds. Okay, this application will load this .env file to get all these properties. So that's what this line here is. So when you do that, we're able to get the region out. We can get the name of the Kinesis stream and so on. Okay, that's already running. And if we go to AWS, you'll see that there's I have a few streams going on here. The one that we're looking at is this one, Hubert Wikipedia. Okay, so that gets us to this. From here, we're consuming the feed. We're running this application. This is already running in an EC2 instance in AWS, and then we're sending that data into Kinesis source. Now we need to really configure Decodable to read that Kinesis source. So this is what we do. We have to have the first, if you look at the documentation here, this is the Decodable's documentation. You have to set up some security, an IAM role, and some permissions. And that's, let me just walk you through that. I did this last time. It's pretty easy, but I'll do it again here. So hopefully it won't take too long. Go to our IAM. Go click on roles. You can see that I've created a few here already. I've already have a Kinesis role, but we'll do this from scratch. Click there, create one, create a custom trust policy. And from our documentation, you want to just grab this guy here, copy that, and paste him in here. This account will correspond to your Decodable account. So when you go into Decodable, this is my Decodable account. It's called, grab this string right here, Decodable demo. Copy that, paste that there, click next. Then it asks you to assign the permissions. I already have a few permissions here defined, but let's just create one just for fun. Click on the JSON, and then you can just go back to our documentation, copy our permissions policy here, and paste it. Add tags, and then you just name this. I'll just name this Hubert Demo Day for Kinesis. Make sure to delete that later. Now that we've created it, we can go back to our permissions policies. We load this list. You can see I just created this demo day one and click next. And I give it a new role name, Hubert role for demo day Wikipedia. And that's really it. You create that role. You can use that role to gain access, to have Decodable get access to your Kinesis. That role is, where did I see? Here we go. Grab this value here, the ARN. Okay, so when you go into Decodable, these are the major components in Decodable, your connections, which are connections outside of Decodable. It brings data into and sends data out of Decodable to wherever they need to go. In this case, we're pulling data from Kinesis into Decodable. Streams are like table structures of our data. This is where our data kind of buffers and lands. And pipelines are basically SQL statements that join and enrich and transform your data between these streams. Okay, so if you go to the connection, you go in here, you want to pick a Kinesis. This is going to be a source. You give it the stream name. I think the stream name that I gave it was just Wikipedia. Let's just check. Can't remember now. Did I get to that page? Get started. Oh, I got kicked out. Yeah, restart. Oh, I'm in the wrong region. Oregon. Here we go. So this is the stream was Hubert Wikipedia. That goes in here. Region is US West, US West 2. And this is where you would paste your IAM role that you just created. This one. Copy that. Goes in there. Our value is JSON. So next. And then you could specify a pre-existing stream that you've created. These are a bunch of streams that we created already. You can create a new stream. Wiki. Click next. And then you'll have to define your schema. So I've already done all this. I don't want to spend too much time. It's already validated that we had that connection with Kinesis. If you want to look at it for real, it's already running. It's right here. I've already defined the schema, and we'll look at the payload in a second, and that the credentials right here. Okay. So that gets us here. So if you look at our connection, we have one outbound stream. So if I click here, if you recall, streams are where the data goes after they've been brought in from a source connection. And this is what it looks like. This is the payload. So it's not simple. Some complex types in here, links, and here's an array. Here's another object. Here's another array. How do we use that as like a we want to clean this up, obviously, before we get into Tinybird, because Tinybird probably wanted that data to be flat, easy to consume and aggregate. You want Tinybird to really focus on serving this data really fast and not having to transform too much of your data, especially if you have complex types in joins and aggregations like these. So what we're going to do is, and if you look at the schema, we predefined the schema for Decodable to really understand. So let's look at the sample data in here. I think there's a sample. Let's see. Oh wait, it's down here. So there's that sample payload, and we're going to define that in Decodable with its specific data types. Okay. The title is just a string, but title detail is an object here, right? So these objects, we use the type row. And inside row are each field in that object. So type, language, base, they're all strings in this case. Okay, value. And that's the end of the record. So that tells Decodable in our internal systems to say, hey, this is a object type. There's only one thing. This is how you parse it so that I can reference it in our SQL pipelines to create SQL. Likewise, we have an array of links here. So the way we do that is we have an array, and inside that array, we define the type. And that type is yet another row, because this is an array of objects inside this payload. So we say row, we have rel, which is a string type, and then href, also another string. If we continue this down, again, here's another complex type we're going to define as a row. There's an array of ints, which is published, parsed, and the authors, and so on. Okay. So all of these data types should be able to handle every type of any complex object that you're sending or payload you're sending to Decodable, so that you could use your pipelines, or AKA your SQL, to transform that data. And that's what we'll look at right now. So we've created a source, a Kinesis source, and now we're going to look at a pipeline and transform that data. This is the pipeline. It takes data from a stream or writes it to a stream. And it does so by using SQL. Okay, so if we look at the SQL, this is what we're doing to the data. We're reading it from Wikipedia raw. And if you recall, Wikipedia raw is this guy, the stream that we're reading from, that's getting populated by the Kinesis connection. Okay, so back to the SQL. Oh, by the way, these are like our data pipeline lineage or flow lineage, where your data is flowing, and we use them as like a forward and backward buttons in Decodable, so you know how to get back to where it was and the next step, right? Before we go to the next step, we want to take a look at what this pipeline, this SQL, is doing to the data from Wikipedia raw. So first, we're doing a simple select statement, and we're doing some conversions of data. So inside published, we have, if you recall, a timestamp. So we need to be able to get Decodable to understand that and actually convert it to a timestamp. And this string here uses a Java syntax that called simple date format, and parses it. So if you go, there are actually free tools out there that help you build this pattern in order for you to parse your data. So here's that page here. So if, say, I take this value here, I copy it, I paste it in here, and I can start to use some syntax here. Capital E is the day of the week, the name of it. Lowercase d is the date. There's a 2-digit date here as well. And August is the MMM, which is this one, abbreviated month name. The year, 4-digit year, 2-digit hour, 2-digit minute, 2-digit seconds, and the time zone. Okay. So when we put this pattern in here and put an example in here, you could hit enter. So if I didn't have this in there, see, if I didn't have, so you have an empty pattern there, right? So it's expecting you to put something in there. So if you put all that back in there, it's able to recognize that timestamp. And that's what Decodable will use to transform that string into an actual timestamp data type inside itself. So we look at that and we paste that value in this field here. So this function takes the column name and the pattern of your timestamp. Then this is how I want it to appear as a column. And now this will become a timestamp after it runs. Okay. I also want to parse the URL. If you look at the ID field here, which is this, it has some information in it. The query string has some interesting information that I want to capture. There's also this is like the diff ID, and this is the old ID. It's kind of holding its own versions of each page. So I want to capture that in case I want to reference it later, and that's what I'm doing here. I'm capturing the diff field, which is the new ID, basically, the old version or the old ID, and the URL title, which is this. What I want to capture is really this part of the title, which really is a category that we could use to further aggregate types of pages being changed. So I want to capture that URL title. Okay, so that feeds this outer select statement here. So I want to capture all of this, but now I want to also consume this URL title that I used down here. So this URL title is now being used up here, and that URL title I want to parse out this prefix here. In this case, it's called user talk. and split it out. We could take it out. We're using split index here to take out the prefix, and then we're using locate the colon out of this string. And if it's greater than 0, then it must exist in there. If it doesn't, we're just going to set it to null. What null means in this case is really it's not the page doesn't have a category. It's just a regular Wikipedia change. There are a lot of administrative pages that Wikipedia uses that it categorizes. In this case, this is about a conversation that's happening between people about a topic. Okay. So those are all the transformations we're running, and when we look at how this is running, we will look at it the next stream. This is again a stream. We flatten the Wikipedia payload into like a single simple type of just strings and booleans and data and timestamps and so on. Okay. Notice that here's a type here. There's a type called category in the URL. So this is the page that it looks like an internal admin page for Wikipedia. It's got that category. And there's more. This is a user page. There's a few nulls here usually. Can't find one right now. Well, we'll see that in the web application at the end. So now that we have a stream with flattened Wikipedia changes coming from Wikimedia or MediaWiki, we're sending this to 2 places. If you recall, we're doing that here. We're sending it to S3 and Confluent Cloud. So we're going to do S3 first. In S3, we have to have the same kind of permissions that we had to set up for S3 for Kinesis. We can go back to here. We can go back to our role here. And if you recall, we have this Kinesis. We can just add permissions, policies. I already have one built out for Hubert, so I can just actually add that to my policy and just use my same ARN when I configure this this connection. So if you look at the details here, I can just use the same Kinesis role that I had the last time. Okay. If you look at this, it's got a region, the bucket that I would like it to write to, the directory in which inside that bucket, and then a way to partition that data, and then some other formatting properties here. So let's go take a look at the S3 bucket. So here's my bucket. Here's my directory within that bucket. And here are all the directories within that. Okay. You click down in here. If you recall, it's partitioning like year, month, and date. A year, month, date, and there's your data. You can click that and download it and see the data that you just transformed. We could do that if you'd like. Take a look at that really quickly. Okay. I need a different way of looking at it. Downloads, data dot. There's that data. Let me pipe it to a query. Okay. Notice that in the summary, there's a lot of HTML value there. We're actually going to make use of that and build our page so that we don't have to format the summary of that change. Okay. So next, we want to go to Confluent Cloud. Confluent Cloud is pretty straightforward. Just sign in. Environments. I have one cluster running in the US West. And then I already have a topic here called Wiki. And then in here, you can create an API key. Just add a key here and then copy and paste the key in the secret that provides you. And that's what you would put inside your go back to here, your Confluent sync. So if you look at these details, it's the same key. There's the endpoint that you need. You can get that endpoint in the cluster overview settings. You want this one right here, the REST endpoint. Okay. The topic that you would like it to write to is JSON, and then you don't really need this guy down here. Okay, so it's really simple to put together. You also need the cluster ID, which is right here. Okay. So that's the Confluent sync. But what's happening here is that we're sending it to 2 different places, and then Tinybird is going to read that data from Confluent Cloud. So let's go ahead and take a look at, for the first time, Tinybird. So in Tinybird, it's a way is to kind of provide your data in real time, but not just provide it in a way that it's really easy for you to consume in your application, because it can create REST endpoints as a way to get to your data. Okay, so I already have my data in here, but I'll show you how I got to it. Just click that little plus button. You could send data to Tinybird using a curl, or send data directly to Tinybird if you don't need any aggregation or transformation. Here's a JavaScript version for, say, Node.js and Python. Okay. But what we're doing is we're sending it to Confluent Cloud, and this is the same information that we provided. Here with the Bootstrap server, I'm using the same server key and secret. Okay, click next. It'll find the topic for you. Just leave it there. Continue, and it'll load that data into like a tabular view. And then in here, you can see the original value. It could read that data already and put it in a table, right? What you need to do is that some of these fields may come in nullable, so you should select some of these and set, for the ones that are string, just set them to null. Else it's going to expect them there. And it'll get quarantined. Any issues with bad data, Tinybird is smart enough to quarantine that data for you and kind of warn you that there's issues with your data. We're going to cancel this actually, because I've already done all this work, and it looks like this. Notice that I've put my nullable fields where I think they might be nullable. My ID should never be nullable, and so on. And the publish time, this is also Tinybird is able to recognize that this field is a date and time, and understand that it's going to use that as the timestamp. Okay. When you go into our Decodable examples page, this examples page is actually this directory here is actually a Tinybird project, and has data sources in it. So it has that all configured for you. And I believe it's pipeline, pipes. So I'm running some pipes in here, so you'd be able to just build this off from scratch using there's a Tinybird CLI you could download. Okay, and that's actually part of the intro here. If you'd like to install it, you could just pip install it if you use Python. But basically, you could create pipelines in Decodable as well, or I'm sorry, in Tinybird. So when you click at this, you create a pipe. And what this does is just formats for different types of REST endpoints that you would like. So I'll show you those here. So I have a feed where I would like to show the count per second, how many changes per second this we're capturing through the RSS feed. Okay, and this also creates me, and I created a REST endpoint to that. Right. So what you could do is this select statement here is now a REST is exposed as a REST endpoint for you to get the result from. If you click on this, I could unpublish this, but it's published as a REST endpoint. So if you look at the view API, this is the activity for that REST endpoint. So this is how many results, the megabytes per second, and latency, and so on. Right. This is like the HTTP. If you'd like to go to that link directly, you can go to use some JavaScript to read it. You can use Python to read this data. What I've decided to do is just cheat a little bit and capture and grab their sample HTML page. Right? This gets the HTML. So I can create a web application based off of this information here. Okay. So that's what I'm going to do here. So I have a few endpoints that I created. I have one for author. It looks like this, the count per author. And I also have one for a parameterized one. So this endpoint here takes a parameter, which is the author of the page. So basically what I'm doing is like when I send over an author to Tinybird, it sends me the last 10 edited pages that person changed. Okay. And we're going to grab that summary over here. Okay. So that got us all the way to the web application. Let's take a look at the web application right now. So this is the web application. I think it refreshes every 20 seconds. This is a per second change. So this is what's happening every second. I'm only polling every 10 seconds to kind of reduce the number of calls I make to Tinybird. And if you recall, in Tinybird, there was a Liz was the top. What was Liz? This one. Liz is the top author. This is by the hour. So in the last hour, this is the most people, top 20 people that are changing pages in Wikipedia. Okay. So what we could do is let's see what Liz has been up to. So click on Liz. Opens up a different page. But what's happening here is that I've sent over a parameter. The author is Liz. And in the background, let's look at that page. Author page. I am. Where did I get that? Here it is. I'm getting the URLs, the parameters from this URL up here, or this URL up here. I'm getting from the parameters, I'm getting the author. That's the auth. Here's the URL to the Tinybird endpoint for looking up author activity, which is this one. And I'm appending that search parameter to the URL. Okay. And then when I get that result, I'm just iterating through that and creating a table down here. Okay, pretty simple. It's the most you could ask for from a data engineer. Not going to get anything better than this, I think. Get somebody else to do it. So basically, here's some of that HTML that's embedded inside the comment that we've now embedded inside a cell in a table. Okay, it looks like this person knows a lot about the kidnap movie about kidnap. This person, I don't know, it looks like soccer players, football players. Oh, man, this guy is pretty busy. I don't know what this person does here, but you can watch them kind of figure out what they've been doing, how busy they are in Wikipedia. And this is the same kind of page, the change page that we're showing here. Where was that? Down here. Yeah. So we just ran through the entire pipeline from Wikipedia all the way to Tinybird. We also sent that same enriched and aggregated and sorry, not aggregated, but transformed data to S3 in case you wanted to do some machine learning or some training or other analytics. But you could actually view all this in real time using Tinybird and Decodable, and and see it work in real time. It's really kind of interesting to be able to do all this pretty fast. It's just all real time, all streaming from beginning to end. And that's it. Does anyone have any questions? Well, if not, we're always watching our community Slack channel. Definitely drop your questions there if you do. And if you would like help in building something similar, definitely reach out to us and also Tinybird, and they'll be happy to help you. Thanks a lot.